Hey everyone, this lesson is about graphs and trend lines. This is a really important lesson in understanding how to look at graphs. And in this lesson, the mastery check is going to be that you create a graph. You won't need to create a graph for every lab that you do, but it's really important for this course that you understand how to read graphs, how they are made, and the kind of information you can get from them. And that's what this lesson is about. So, our central question is, how do we use graphs to show the important trends in our data and make predictions? So, in scientific graphing, the vast majority of science graphs are what are called scatter plots, which can present a lot of data very efficiently. So, this is an example of a scatter plot. And what you can see here is a lot of range of how these dots, but there's a definite pattern where we can see that as the grade point average is increasing, the number of hours of video games that are being played is decreasing. So draw that trend line, kind of that general pattern of how the grade point average affects the amount of hours of video games being played. So to create a scatter plot, you need to do this. You need to identify which variable is the independent variable and which one is the dependent variable. My hint is usually the variable that you measure is dependent. Now, what's not written on this screen here is that the variable that we are intentionally changing is the independent variable. And I think that's worth you writing in there. So I'm going to go ahead and I'm going to call independent, I'm going to call that the IV for short. So the IV is the variable, I'm going to try to write quickly on the screen. Variable, you change. You should write that into your notes. Okay, great. So in this case, we have a data table here of distance and average time, and the question of which one is the independent and dependent variable. In this case, it really could go either way, but we've set up goodness gracious, okay. We've set this up so that the independent variable is on the left and the dependent variable is on the right. That's usually how, in fact, that should be how you set up your data tables. Okay, let's go ahead and clear my screen. Okay, so when it's time for graphing, you are going to label your x-axis with the independent variable and your y-axis with the dependent variable. Make sure that you include the units they were measured in. So my independent variable will go down here, which would be distance in this case, and my dependent variable goes on the y-axis, so that's going to be time. And notice that I, in parentheses, put the unit that I measured distance and time in. Then you need to graph your data. It's helpful to use a small x instead of using a dot for the data point so that you don't cover them up with the trend line. Draw a dashed line or curve that shows the overall trend of the data. This is really important. It should not connect each data point, and it may not even go through any of the data points because it's called a trend line, as in it's showing the trend or a trend curve. If you are trying to make your trend line straight, it's really helpful to use a ruler. If you're trying to make it a curve, then you should freehand it. Your graph's trend line is the most important part. You can use it to make predictions about the variable values without having to take data, and you can use it to figure out the mathematical relationship between the variables. So let's talk about some of those mathematical relationships. A no relationship, which we often call the horizontal relationship, would look something like this. So no matter what the independent variable is, the independent variable is changing. The dependent variable does not change. So notice it's always kind of right around that same number. This looks like a horizontal line on a graph. A proportional relationship between the two variables is when the independent variable doubles, so does the dependent variable. And this looks like an upward diagonal line on a graph. When we have an inverse relationship between two variables, that is when the independent variable is doubling, or you can see that the independent variable is increasing, and the dependent variable is being cut in half. And so you'll see that the dependent variable is getting smaller and smaller as the independent variable increases. This would look like a curved line going down on a graph. And the last one, the quadratic relationship between two variables. Remember, I said in the last video that this is really rapid growth. This is kind of how that looks. So when the independent variable doubles, the dependent variable quadruples, and you get this kind of upward curved line, or curved line going up on a graph. So that's kind of the general patterns that you should be expecting to see in your data in all of our labs. It's going to fall under one of those 4 patterns. There are more common patterns in nature, but those are the ones that we're going to address and we're going to see in this course. So, in summary, how do we use graphs to show the important trends in our data and to make predictions? I didn't really talk about how we use that to make predictions, but I'd like for you to think about that part as you're writing your summary. Be sure to do the practice on the next page of practicing making a graph before you jump to the mastery check.